Myself Khushi Banerjee. In today's class, we will study about what is the difference between N-type and P-type semiconductor. So for N-type semiconductor, the majority carrier, it is done by the doping due to the pentavalent impurity. So in this case, the majority carrier are the electrons, while the minority carrier are holes. While for P-type impurity, it is being done by doping it with trivalent impurity. For those P-type, the majority carrier are the hole, while the minority carrier are the electrons. In case of N-type semiconductor, the Fermi level lies near that of the conduction band, while for P-type semiconductor, the Fermi level lies near that of the valence band. So this is the band representation for the N-type, P-type and the intrinsic semiconductor. In the diagram A, we can see it is of the intrinsic semiconductor, where the conduction band and valence band in the middle, we can see the Fermi level shown with a green dotted line. We can see that is the Fermi level lies exactly in the middle of the conduction band and that of the valence band. While in case of N-type, the Fermi level moves towards the conduction band. In intrinsic semiconductor, the Fermi level lies in the middle of the conduction band and valence band because the probability of finding any state, that is the electron, is equal to the probability of finding an hole. So the Fermi level lies in the middle of the conduction band and valence band. While in case of N-type semiconductor, we can see that the Fermi level moves closer to that of the conduction band. This is because the probability of finding an electron is more in case of N-type semiconductor, so the Fermi level moves towards the conduction band. While in case of P-type, the probability of finding an hole is more than that of the electron. So the Fermi level moves towards the valence band because the holes exist in the valence band. So the Fermi level moves towards that of the valence band in case of P-type semiconductor. Now what are the various transport phenomenon in case of semiconductor? It is basically of two types, that is the drift and the diffusion. Now what do we mean by drift? The movement of charge carrier under the influence of electric field is known as the drift of the carrier. So in this case we can see that a semiconducting material is connected to a battery. The electron, being negatively charged particle, will move toward the positive of the battery, due to which the direction of the current will be in the opposite direction. While what is diffusion? It is the flow of carrier from a region of higher higher density to lower density. Like we know that when a water tank is filled, is being connected to an empty water tank, the water flows from a region of higher concentration to lower concentration region, unless and until the water level is being equal. So the same thing happens here. The electron moves from a region of higher concentration to a region of lower concentration region to maintain the uniformity of the concentration. So what is carrier diffusion? We can study that in detail. We can see it is being represented with a graph. Along the x-axis is the position x, along the y-axis is the electron concentration. So from the graph we can see that the concentration of electron, in which side it is higher, the electrons are moving from that region to the region where it is being lower. And the electron current density, diffusion current density, will be just the opposite to the flow of electron. In this, the electron is flowing from right direction to left direction, so the direction of current will be just the opposite, that is from left to right. The electron diffusion current density equation, here it is shown with minus of E dn minus of dn by dx. So it becomes E dn by dx, where dn, it is the electron diffusion current coefficient. Similarly for hole, we can see that is the hole concentration is shown with respect to x. So the Jp diffusion due to the hole, it is represented by minus of E dp by dx, where dp, it is the hole diffusion coefficient for the holes, and the direction here, it is having a negative direction for the diffusion current for holes.